This may sound redundant, but in C, every pointer points to something. So even a pointer like this, that has no value, still points to something. And in this case, that's most likely to a random spot in memory. And the problem with this is that if we try to use this pointer, we'd get an error because it's not pointing to anything useful. And another problem is that in our program, there's no way for us to tell whether or not this pointer is pointing to something useful or whether it's just pointing to garbage in memory. So because of this problem, they created a value called null, which can be given to any pointer. And we can give it to it like this, just by typing the word null. And this simply lets us know that this pointer is pointing to nothing. It's not being used. And later in the program, for example here, we can do an if statement to test to see if the pointer is equal to null. And there's a lot of functions in C that work with pointers, and when they encounter an error or something like that, they will return null to let us know that an error occurred. Now imagine a function that returns a string. If there is an error so that a string cannot be returned, it has to return the null value, because otherwise we have no way of knowing that what it returned wasn't a valid string. Alright, and an example of this is the malloc function that we used in the last tutorial that allocates memory. If for some reason that function fails to allocate the memory that we requested, it will return a null pointer. So let's call that function with a number so large that there's no way that we can possibly allocate that amount of memory. And we'll see if it gives a null value. So let's create a pointer, and we are going to give it the address of a block of memory, and we're going to request 4 gigabytes of memory. And there's almost no way that our operating system is going to let us use 4 gigabytes of memory for our program, unless your computer is just a ridiculous gaming machine that has like 16 gigabytes of memory. So since we're working with bytes, we need a 4 followed by 9 zeros. And this will normally cause a problem unless we specify that this is an unsigned integer. Because normally when you're working with integers, whether they're negative or positive is stored in memory. So we're telling this integer that that does not need to be stored. So we can use that space that would store the plus or minus sign to store the number itself. Because normally we don't work with numbers this large. Alright, so we just tried to allocate 4 gigabytes of memory for our program. So now we're going to test to see if that malloc function returned null. So all we have to do, if I can type, which I can't today, if it equals null, we're going to print out we couldn't allocate the memory. Alrighty. So let's run this program and see what happens. It compiles and we run it, and it says we couldn't allocate the memory. Just to make sure that I didn't make a mistake, I'm going to decrease this number by a factor of 10. So now I'm asking for 400 megabytes of memory. And if I compile this again and run it, we get no such error message. So in this tutorial, we learned about the null pointer, which is used for pointers who aren't pointing to anything, and they're often returned by functions that work with strings and other pointers just to let us know that an error occurred. And we also did this crazy example allocating 400 megabytes and 4 gigabytes of memory for our program, which normally is a bad idea, but we use it to show that there are functions that will return null, and we saw that happen. Well, I hope you've learned something in this tutorial, and we'll be using the concept of the null pointers a lot in future tutorials, and I will see you then.